Hello, students. Very good evening, good morning, good afternoon, whenever you are watching this video. Now, in the last class, we have seen hydrocarbon part 1. Now, this is our part 2. Now, in the first class, I have told you that I will try to complete hydrocarbon in one video. But after seeing that time is going to be 1 hour 42 minutes, so I have stopped that video in part 1. Now, we are going to see the next part of the hydrocarbon, and again I am suggesting those who have not watched the first part, please leave this video. No use, don't increase my views, I didn't need it. Just leave this video, no use of that. Now next part I am going to see in hydrocarbon, hydrogenation. Next part we are going to see is hydrogenation. What is hydrogenation? Up to Grignard reagent I have completed in the last class. Now we are going to see the next part of the topic, that is called hydrogenation. Hydrogenation means addition of hydrogen. And again I am saying, those who have not seen the first part, no need to see it, please. You will not get anything. It will become boring. Acha, addition of hydrogen. Where you will add hydrogen? In alkene as well as in alkyne. Means, just see it very properly. Topic is going to be very easy. Addition of hydrogen in alkene and alkyne. We have to add hydrogen in the case of alkene and alkyne. In this hydrogenation topic, we will use the reagent. What we will use? Reagent, and that reagent we will use hydrogen in presence of either nickel or platinum, palladium or platinum. We will take hydrogen in presence of nickel, platinum and palladium. If they will ask in which case the reaction will happen faster, rate will be faster, means addition of hydrogen rate will be faster in which case? So hydrogen in presence of platinum has more, then hydrogen in presence of palladium, then hydrogen in presence of nickel. Now see what is happening in this case. Now, suppose you have taken one plate or something, you have taken bed sheet or bed. On that bed is made up of platinum, palladium or nickel. On that bed you will add hydrogen. What you will do? Suppose there is a plate. I will dictate you. This plate has, like that plate is there. Now in that plate you have put hydrogen, lots of hydrogen molecules you have put it. And over here you will take alkene or put it over there. What will happen? Hydrogen from here attach here. Or you will take the plate. You will take the plate over here, and on that plate you will put hydrogen molecules. And this is red color is hydrogen molecules and blue color is plates. Plate or bed sheet, anything. And over here you have taken triple bond and you will try to attack hydrogen. So over here how many moles of hydrogen? 4 hydrogen will attack. Over here 2 hydrogen will attack. This is known as hydrogenation. Now you are putting this, what you are doing? You are putting the alkene or alkyne in front of the plate. That plate has distributed lots of hydrogen. So it will attack from the same side or opposite side? Same side. So hydrogenation is seen addition. Sir. Not understood. Again. I am saying that hydrogenation means addition of hydrogen in alkene and alkyne. Reagent we will use H2, nickel, platinum, palladium catalyst. In that H2 platinum is more than H2 platinum, then H2 palladium, then H2 nickel. This is the rate faster. What is the hydrogenation process basically? I have taken one bed sheet or I have taken one bed over here like this. This is our bed of either made up of platinum or nickel or palladium. On that bed I will put little bit amount of hydrogen and I will take the CH2 over there in front of them. Then whatever with the hydrogen they will attack over here. Over here how many hydrogen will attack? 2 hydrogen to make double bond as a single bond. Over here how many hydrogen will attack? 4 hydrogen to make a triple bond as a single bond. So it will attack on the same side, or this hydrogen will do a rotation and it will attack from this side? No sir. So on the same side attacking is known as syn addition. Understood the point? Yes sir. Now over here we know that ki alkene and alkyne cannot be formed by one carbon. So what you will say? Ki in this reaction CH4 is still not formed. It means up to now which reaction is forming CH4? Only one reaction is forming CH4, and the name of the reaction is soda lime decarboxylation. Remaining Grignard reagent also forming. After that, slowly you have already seen the previous part. So up to now you have understood ki what is the reagent we are using, what is the reactant we will use, alkene or alkyne, and why it is known as syn addition, because it is attacking it is attacking on the same position, and this process, hydrogenation process, is known as adsorption. What do you mean by adsorption? Suppose I will put water on the cloth. What it will do? It will absorb. Water will go inside the cloth. But if I will put surf on the cloth, what it will do? It will stick to the surface. So adsorption is this over here. What is happens? It is happenings adsorption. Adsorption means sticking to the surface. Adsorption means sticking to surface, and it is doing syn addition. Which addition? Syn addition it is doing. So I hope everyone has understood up to now what I am trying to dictate. Once you will see this part, then we will proceed further. So we have seen hydrogenation is a syn addition, sticking of hydrogen to the surface of alkene and alkyne. Reagent used is nickel platinum catalyst in presence of hydrogen with the help of alkene and alkyne. Now see what I am going to do. First I will take CH2 double bond CH2. And now I will react this with H2 in presence of nickel, either platinum or palladium catalyst. How many moles of H2 I have to take? Sir, only 1 mole, because 1 mole of H2 will give 2 hydrogen, and they will need only 2 hydrogen. So what you will get? CH2 single bond CH2, 1 hydrogen will come here, 1 hydrogen will come here. This can also be written as CH3. This is known as hydrogenation process. Suppose I will take another example, CH triple bond CH triple bond CH, and I will react with H2 in presence of nickel, platinum or palladium catalyst. Over there how many moles we have to take? Sir, 2 moles. If it is given 2 moles also okay, not given also don't get panic. You will have to understood it is 2 mole. What will happen? CH single bond CH, 1 hydrogen here, 1 hydrogen here, 1 hydrogen here on the same side. It can be also written as CH3, and this is hydrogenation process. But someone will say, sir, I want to convert alkene into alkane. This is okay, but I don't want to convert alkyne into alkane. I want to convert alkyne into alkene. What I will do? So understood? Means someone is asking me this question, sir, how to convert alkyne to just alkene. In every part, first part and second part, we are converting alkene. This is alkene, and after alkene it is converted to alkane. In the second part it is alkyne, and it is also converted to alkane. Someone will say, no, I want to convert alkyne into alkane. No, alkyne into alkene I want to convert, not alkane. What I will do? So we have to change the reagent little bit. What is the change in the reagent? We have to take reagent used over here for this process is called, either you will take PD in presence of BaSO4, and that will be poisoned by sulfur, or sulfur like that star written, or poisoned poisoned by quinoline. Quinoline has a structure like this. Nitrogen over here, this ring. Sir, what will happen if I will do this reagent? So whenever you will take alkyne, CH triple bond CH, and you will take hydrogen in presence of PD, BaSO4 poisoned by sulfur, like that written, or quinoline structure given, so it will take only one hydrogen over here, and it will become alkene, that is CH2 double bond CH2. It means alkene to always converted into alkane, but alkyne is converted into alkene. Sir, what is the reason behind it? What is the use of this reagent? Whenever you are taking platinum or palladium catalyst, that plate, this is made up of platinum, palladium or nickel catalyst. In that situation, plate size does not any holes and all hydrogen is present over here. But whenever you are taking PD in presence of BaSO4, their plates has little bit holes. Their plates has little bit holes. This is made up of PD, BaSO4. And then whenever you are putting hydrogen over here, what happens? Some hydrogen will stuck in the holes. So whenever you are taking CH triple bond CH, only one hydrogen will come here. Two hydrogen is not coming. So overall, you have to know hydrogenation is a syn process, syn addition of hydrogen into alkene and alkyne. Reagent used is H2 in presence of nickel, platinum or palladium catalyst. The rate will be more in platinum, then palladium, then nickel. Over here both are adsorption process sticking to the surface, syn addition. CH4 is still not formed in this case. Alkene or alkyne, both is converted into alkane, but if we will have to convert alkyne into alkene, then we have to use one reagent, and the name of that reagent is PDBS4 in presence of poisoned by sulfur or poisoned by quinoline, and the name of this reagent is known as Lindlar's reagent. The scientists, those who have given this reagent, their name is Lindlar's, and on his respect, this reagent is known as Lindlar's reagent. So I hope you understood hydrogenation of alkane. Over here also syn addition. Every place syn addition and every place adsorption. Adsorption means sticking to the surface. And as I have told you, if you have any confusion, you can ask me on 9267 937718 is my WhatsApp number, or don't call. Calling is not allowed. And when I will come to the college, over there also you can ask if you have a confusion. So I hope you understood this, all the things about this part. Now I am going to dictate to you one that important topic that you will write very important. What is very important? Something I am going to teach you, and that topic name is stereochemistry. And that topic is very important. What I am just see up to now, hydrogenation understood? Sir, understood. Whenever we will take H2, PT, PD, and I in presence of alkene, alkyne, both will convert it into alkane. And whenever I will take PD, BaSO4 poisoned by sulfur or quinoline, alkene converted to alkane, but alkyne converted to alkene only, not alkane. Okay, sir, I understood this. Now, one thing I am going to write, and that topic name is stereochemistry. And I have told you, whenever I am writing important point in chemistry, it is known as stereochemistry of whole hydrocarbon. Whole hydrocarbon. This is not for hydrogenation. Sir, what you are writing, I am not getting it. Just wait. I will make you understood. Now, whenever I will do any topic I will do, any chapter I will complete. Suppose I have completed over here, and the name of the chapter is called hydrogenation. In hydrogenation, what I have written? Hydrogenation is a process. That process will do syn addition. Syn addition. Like that, whenever I will teach you any topic, I will write before that it will do syn addition or anti addition. Syn addition means same side, anti addition means left side, means opposite side. For that I am going to give you stereochemistry of hydrocarbon. What do you mean by that? Just see once, you will understand it. Suppose I will write over here types of alkene. After writing types of alkene, I am going to write types of addition, and then I am going to write types of reaction. Means, suppose someone will always say, we know that there are two types of alkene. One is known as, this design is cis and this design is trans. Means C double bond C, same side CH3, CH3, H and H. This is known as cis. C double bond C, CH3, CH3, H and H is trans. This is their bond line structure upside. So what I am trying to say in this part, try to understand it very properly. Suppose alkene will be given either cis, or alkene will be given cis, or alkene will be given trans, or alkene will be given trans. Two times why I am writing, I will dictate that. Whenever cis given, consider cis as positive, cis as positive, trans as negative, trans as negative. And any addition, type of addition like that, hydrogenation is doing what? Hydrogenation is doing syn addition. Similarly, every reaction that is fixed. So similarly, some reaction will do syn, some reaction will do anti, some reaction will do syn, some reaction will do anti. Now, if cis and trans is not given, suppose for hydrogenation cis and trans is not given, then always do syn. But if cis given, so take syn as positive, anti as negative, syn as positive, anti as negative. Now positive and positive, what it will become? Positive. So it will become syn addition. Positive and negative, it will become what? Negative. So it will do anti addition. Negative and positive will become negative, it will do anti addition. And negative will become positive, it will do syn addition. Means, for a reaction, syn and anti is fixed. Like for hydrogenation, syn is fixed. You can't change, it will become anti or this. But cis and trans you can change. Means again, suppose I will say, I have taken one structure over here, alkene, and I am reacting that alkene in place of hydrogen. We know that hydrogen has three isotopes. One is called hydrogen, protium, deuterium and tritium. These are the isotopes of hydrogen. Isotopes of hydrogen. So in place of hydrogen, I will take D2. And I am saying it will nickel, platinum or palladium catalyst. And same situation, I have taken another example of trans. This is our trans. And I am reacting that trans also with D2 in presence of H2. I have taken D2, so you are able to visualize कि syn anti happens, how happens. Palladium. Now what you will say, once you will see it, you are 100% sure कि sir, this is hydrogenation, it will do syn. This is hydrogenation, it will do syn. Because for hydrogenation, syn is fixed, syn is fixed. But this structure is cis. Cis will become positive. This structure is trans. Trans will become negative. It means in the first case, this is CH3. The first I am writing over here CH3. Then over here we have one carbon. After that another carbon. This carbon and this carbon. After that again we have CH3. Now see over here. In this carbon and in this carbon, 3 hydrogen I have put. In this carbon only one hydrogen, so I will put one hydrogen. In this carbon only one hydrogen, so I will put hydrogen. D2 will come either both this side and hydrogen will come here, or CH3, understood what I am saying? CH3, H will come here and D will come here. Means again understood the point. Both are same, identical structure. Both are identical structure. How, sir? I have dictated you what is identical in a structure. Identical structure are those structure which will form a mirror image, but they will not show optical isomerism. It has a plane of symmetry, and because of plane of symmetry, it has this chiral center, this chiral center. So this is a meso compound. Meso compound is those compound those who have two chiral center and plane of symmetry. So this is this is optically inactive compound, and mirror image of optically inactive compound. Mirror image of optically inactive compound is always a identical compound, and that can also written as homomers. Don't worry, if I have not completed GOC, I will complete that. Means what I am trying to say, either you will draw this or you will draw this. No need to draw all. So I am cutting this. I am not cutting here, but I am just cutting it. Ki no need to draw this part. Only one you will draw. This is called scene addition. Why scene addition? Because plus and plus will become plus. But if you will see the second question, I am erasing it because a space has been filled, and I am writing again. If you will see the second question, what you are seeing in the second question? Sir, in the second question, this is trans. And then you are taking on the arrow D2 in presence of nickel, platinum or platinum catalyst. You know that this is the fixed, sir. This is hydrogenation. Hydrogenation is always fixed positive, scene addition. Similarly, other reaction will be anti, that is fixed. But over here, scene is fixed. But this is trans, and trans is negative. And negative and positive will form negative. It means this is CS3, this is CS3, right? Upside CS3, downside CS3. One place you will add hydrogen and deuterium this side, so one place this side. It means one time deuterium will come this side, the other time deuterium will come on the opposite side. This is known as anti-addition. Two deuterium has been added on the two different side. Now, if you will make their mirror image is coming CH3 over here also CH3 over here. D will become H, over here D, over here H, over here D. What you will say in this case? You will say in this case that this compound is also optically active. No plane of symmetry, no center of symmetry, nothing is there. It means this compound is also optically active, and this compound is also optically active. So these two are optically active compound. Mirror image are optically active compound. Mirror image are enantiomers. Enantiomers, and enantiomers pair will form racemic mixture. So both racemic mixture, combination of both the two compound is optically inactive compound. It means whenever they will give you this question, their answer will be only one, and whenever they will give you this question, their answer will be two. One answer will be this and another answer will be the mirror image. But over here you can't draw the mirror image. Understood the stereochemistry what I am trying to say? It means hydrogenation is fixed sin, but cis and trans to change na. So according to that, sin will also become anti like that. Understood? Similarly, some reaction I will write over there, I will show it will do anti. So according to that, you will cis and trans, you will transfer it. I hope you understand this. Seriously say. Any confusion? No, sir? Okay. So this is our part 2. I hope you understood up to now. Please see it very properly. Now I am going to dictate you the next part, and don't worry about JEE Mains questions. I will do in the class or I will upload on the video, but first I will do in the class also. Those who need, I will upload on the video also. So I hope everyone has understood this part very clearly and very importantly, and this topic is known as hydrogenation. After hydrogenation, I have dictated you sin anti-hydrogenation is always sin addition, always and always. So only cis and trans will be changed. Hydrogenation will not change. Similarly, I will write other reaction. I will say it is anti. So according to that, you will judge. Understood? Ha, sir. Now it is coming. Okay. This video I will stop over here. Why? Because next video it will be 1.5 hour, 2 hour. Next topic is big topic. Okay. Slow. I will complete it so you will not get panic.